Okay, so in this problem it says that a rope snaps when the tension exceeds 387 Newton. So the tension that it can tolerate is 387 Newton, and after that it snaps. In order to lower some material weighing 449 Newton from a point 6.1 meter above the ground, what magnitude of the material's acceleration would put the rope on the verge of snapping? This is number one. And then at that acceleration, with what speed the material will hit the ground. So a material is lowered by the rope from 6.1 meter above ground, and the question is, and the material's weight is 449 Newton. From that we can find the mass of the material. So mg is 449. So m will be 449 divided by 9.8. I will leave it like that for the time being. That much kg will be the weight of the material. Mass of the material. It says at what magnitude of the material's acceleration will put the rope on the verge of snapping. So the material is being lowered. That means the acceleration is downwards. When that happens, we get equation like this. So mg minus ma will be equal to the tension, or we can say that mg minus t will be equals to ma. That means the acceleration is downwards, ma, so ma is downwards and weight is of course downwards. The rope's tension is upwards, so mg minus t is the resultant ma. That's what it is. So we know the at what acceleration the material will the rope will snap. That's what we have to find. So mg is 449 minus 387. From that we can find a. So 449 minus 387 divided by m, which is, I didn't calculate, it will become, that's 45.8 approximately. And this, from here acceleration is 1.35 something meter per second. So we can say meter per second square. So if the acceleration is less than that, because if mg minus ma, the difference between mg, so if ma is less, that is if a is less, then the difference will be more, and then the tension on the rope will be more. So the acceleration has to be that much at least, so that the difference here is does not exceed t. So if the acceleration was more, let's say 1.4, if we take a round figure, then the rope will not snap. So we can say, I will just round up it up to 1.4 second because it is 3.5 something. If I round up, it will be 1.4 meter per second square. So that is the acceleration. If the acceleration is less than that, it will snap. The rope will snap. Now the second part of the question is, at that acceleration, with what speed the material will hit the ground. So the material, if the material falls at that acceleration, that is important. So it's not a free fall. If that happens, then what will be the velocity with which or speed with which it will hit the ground. So if we recall this formula, v square is equal to u square plus 2as, and a we will use this much, not g, because it's not free fall. So v will become, u is 0, so this will become 2 into 1.4 into 6.1, because that's the height, that much. So that's 4.1 meter per second. That's the velocity with or speed with which it will hit the ground.